Our next lesson may seem a bit different to you than our last lessons. Each module in Engage New York is broken down into separate topics. The first topic, Topic A, was all about constructions. Topic B, we're heading into talking about proof, proving something is always true. Now, today's lesson is about solving for unknown angles, and there actually aren't any CCRSM standards directly tied to these three lessons. But I feel like the content in these lessons will lay a foundation for us that we'll build on as we talk about proof in the future lessons. The specific topics that we will highlight in this video and in this lesson are that vertical angles are congruent, linear pairs are supplementary, the measure of adjacent angles around a point is 360 degrees. When a transversal intersects parallel lines, the corresponding angles are equal in measure, the alternate interior angles are equal in measure, the same side interior angles are supplementary, and the sum of the three angle measures of any triangle is 180 degrees. Now, I know there are some new terms for you in this list. For example, vertical angles, adjacent angles, corresponding angles, alternate interior angles, same side interior angles, may be new terms for you, but we will talk about those in this video, and by the end of this video, hopefully you're more familiar with those vocabulary terms. Let's get started. We will start this video with lesson 6. We are asked to determine the measure of the missing angle of each diagram. In diagram A, we have what are called vertical angles. Vertical angles are formed when two lines intersect. The opposite angles have the same measure. So in diagram A, the measure of the missing angle would be 36 degrees. In diagram B, we have a straight line and two angles. These are called a linear pair. A linear pair is formed when two adjacent angles make a straight line. They are supplementary. Now, let me highlight some of these words. Adjacent means two angles that share a common side, or two angles that are next to each other. And supplementary are two angles that add together to be 180 degrees. Okay, so for these two angles, they must add together to be 180, and so y must be 180 minus 121, which is 59 degrees. Okay, finally, diagram C. Here are three adjacent angles. They're all next to each other. And these three angles will add up to be 360 degrees because the adjacent angles around a point equal 360 degrees. Okay, so for angle Z, we would take 360 and subtract the sum of 82 and 172. So 360 minus 254 is 106 degrees, which is equal to the measure of angle Z. Okay, so the three big ideas that we'll learn in lesson 6 are about vertical angles, linear pairs, and about adjacent angles around a point. Two angles, angle AOC and angle COB with a common side, ray OC, are blank if C belongs to the interior of AOB. Well, here's a picture. Here is angle AOC. Here's AOC and COB are adjacent angles if C belongs to the interior of angle AOB. The sum of angles on a straight line is 180 degrees. And two such angles are called a linear pair. Two angles are called supplementary if the sum of their measures is 180 degrees. Two angles are called complementary, that wasn't in the earlier content, if the sum of their measures is 90 degrees. Describing angles as supplementary or complementary refers only to the measures of their angles. Their positions of the angles, or whether the pairs of angles is adjacent to each other, is not part of the definition. So, some important words here are linear pair, supplementary, and complementary. And very quickly, the easiest way to memorize supplementary and complementary is that in the alphabet, C comes before S, and so C is 90 degrees, while S is the bigger one, 180. Those are kind of in the same order, so don't get those two mixed up. Now, I want you to use those ideas and find angle DCE, this angle, in this figure. Ready, set, go. Now, this angle has a box, which means this is 90 degrees. And this makes a straight line, and so these three angles add up to be 180 degrees. So you simply add 72 and 90 and subtract that from 180. And the measure of angle DCE is 18 degrees. Next, we'll jump to lesson 7 about transversals. Given line AB and line CD in a plane, a third line, EF, is called a transversal if it intersects line AB at a single point and intersects line CD at a single but different point. So, in this picture, line EF, or segment EF, is a transversal because it intersects two other lines. Now, if the two lines are parallel, then we have some nice properties that form with either congruent or supplementary angles. Corresponding angles are angles that are in the same place. For example, angle A and angle E. So these are both in the top left position, and so they correspond to each other. They're corresponding angles. Angle B and angle F are in the top right, so they're also corresponding angles. Now, angle C and angle G are also corresponding, and angles D and H are also corresponding, but for the lack of space, I won't write those down. But those are corresponding angles, and when the lines are parallel, then the corresponding angles are equal in measure. Next, we have alternate interior angles. This is thought of as the interior of the two lines. And they are alternate if they're on the alternate sides of the transversal. So, angle D and angle E are both on the interior of the two lines, but they are on alternate sides of the transversal. So angle D and angle E are alternate interior angles. Similarly, angle C and angle F are also on the interior of the two lines, but on alternate sides of the transversal, and so C and F are also alternate interior angles. And those are the only two pairs of alternate interior angles. Now, if the two lines are parallel, then the alternate interior angles are equal in measure. The last angle pairs we have are called same side interior angles. Now, those are still on the interior of the two lines, but they're on the same side. So in this case, it's C and E are on the same side of the transversal and on the interior of the two lines. Similarly, angle D and angle F are on the interior of the two lines, but on the same side of the transversal. Hopefully you've noticed that they wouldn't be congruent because one looks obtuse and one looks acute. But if the lines are parallel, then the same side interior angles will be supplementary, meaning they will add together to be 180 degrees. Now, let's use those ideas in the next few problems. Now, I want you to use those ideas and figure out in number 1 what the angle pair relationship is between A and 48 degrees, and then write down the measure of angle A. Ready, set, go. Angle A and 48 degrees are corresponding angles. And so the measure of angle A is the same as 48, and so this is 48 degrees. Okay, now do the exact same thing for number 2. Figure out what the angle pair relationship is for B and 48, and then find the measure of angle B. Ready, set, go. Thank you. Now B and 48 are both on the interior of the two lines, but on the same side of the transversal. So they are same side interior angles. Now we just learned that same side interior angles are not congruent, but they are supplementary, meaning they add together to be 180. So I find B by subtracting 48 from 180. And the measure of angle B is 32 degrees. Next, we'll discuss lesson 8, solving for unknown angles when we have angles in a triangle. You probably know from past math classes that the sum of the three angle measures of any triangle is 180 degrees. The definition of the interior of a triangle is that a point lies on the interior of a triangle if it lies on the interior of each of the angles of the triangle. In any triangle, the measure of the exterior angle, let me draw a picture. So here's a triangle. This is an exterior angle. And something you should have learned in previous math classes is that the exterior angle is equal to the sum of the measures of the opposite interior angles. Meaning this angle and this angle added together are equal to the exterior angle. These angles are also known as remote interior angles. Another important fact about angles in triangles are that the base angles of an isosceles triangle are equal in measure. Here's a quick picture of an isosceles triangle. An isosceles triangle is a triangle where two sides are the same length, and the base angles, meaning the angles opposite those sides, will have the same measure. And the last really important fact about angles in triangles is that each angle of an equilateral triangle has a measure equal to 60 degrees. So here's a picture of an equilateral triangle where all sides have the same measure, equi meaning equal, and lateral meaning side. So an equilateral triangle is where all the sides are equal or have the same measure. And the angles in an equilateral triangle would also be the same, and so each one equals 180 divided by 3, because the angles add up to be 180, divided by 3 is 60 degrees. So that's why the angles in an equilateral triangle each have measure of 60 degrees. At the bottom of this page, there's some relevant vocabulary. This is an isosceles triangle with at least two sides equal in length. And this is a picture of the exterior angle of a triangle. And let's move on and try at least one problem using these ideas. We only have time for one problem, and I've chosen problem number 2. 78 degrees is an exterior angle because it is formed by extending one side, and it's on the outside of the triangle. Now, you've previously learned that this angle, the exterior angle, is equal to these added together. And so 42 plus A is equal to 78 degrees. And then I use some simple algebra, and A is equal to 36 degrees. All right, this video was about solving for unknown angles and introducing you to some important properties that we will use in future lessons with proofs. Thank you so much for watching.